Welcome to the Deep Dive, where we cut through the noise to get to the core of what truly matters. Today, we're not just exploring new technology, we're diving into how you can harness it for, well, profound social impact.
Yeah.
Imagine building AI solutions that genuinely make a difference in really critical moments.
Yeah, it's a huge area. The world of AI agents is evolving so fast, moving way beyond simple chatbots. We're talking intelligent systems now that can plan, reason, and actually act.
Exactly. And for someone like you, our listener, maybe a Python beginner with around 6 months experience, already good with prompt engineering, maybe you've built customer support chatbots. This next step, it's totally within reach. Your goal is incredibly powerful to creatively and efficiently support domestic violence crisis response organizations with AI.
That's a huge mission. Really important work.
It is. And we're here to give you a shortcut, sort of a way to get well-informed about the advanced agentic design patterns you'll need. We've taken the documentation, the research, the code snippets, all that source material, and distilled it into, hopefully, a clear mental roadmap.
Right. No fluff, just thoughtful insights and structured explanations. Trying to make it digestible.
Think of this deep dive as your expert guide. We want to help you see the most important nuggets, really get a handle on the key concepts, and get ready to develop even better, more impactful AI solutions for those who really, really need them most.
Yeah, you're not just building a bot. It's almost like you're assembling a superhero team for a critical mission.
I like that. And each agentic design pattern is like a new superpower or a key piece of gear for that team.
Makes them stronger, smarter, safer.
Definitely safer.
Yeah.
So what are we unpacking today? We'll start with the foundational patterns, how agents string together actions, how they remember things.
Like giving them short-term and long-term memory.
Exactly.
Yeah.
Then we'll look at how they connect to the outside world, bringing in external knowledge, tools, like a real-time library.
Getting information from outside their training data.
Then we dive into how agents think, plan, work together, their own internal thought processes for tackling complex stuff.
Collaboration and reasoning.
And finally, the really crucial part, especially for your mission, ensuring trust, safety, continuous improvement.
Absolutely paramount in sensitive areas like crisis response. You need those guardrails, ways to learn and grow safely.
Right. Even superheroes need that. So get ready to dive deep into the architecture that will empower you to build AI that truly serves. Okay, let's unpack this.
Okay.
Kicking us off in the foundational building blocks, let's talk prompt chaining. Now, you've worked with prompts, I know, but this is a step beyond, right?
Yeah, definitely. Instead of one giant kind of complex prompt trying to do everything, prompt chaining is like breaking a big problem down into a sequence of smaller, much more manageable sub-problems, sometimes called the pipeline pattern.
A pipeline. Okay, so each step has its own specific job.
Exactly. Each sub-problem gets its own specifically designed prompt, and the output of one step, that becomes the input for the next one. It creates this really logical, structured flow, like a recipe almost.
Makes sense. And it's not just about making it easier.
No, it's absolutely foundational for building, sophisticated AI agents, the kind that can plan, reason, act in dynamic environments. It really mimics how we think through complex tasks.
So why is this so crucial? Especially for an agent that has to be reliable, like in a crisis situation.
Well, it massively improves reliability because the LLM, the language model, is only focusing on one specific operation at a time. That reduces the chance of errors. Trying to juggle too many things at once leads to mistakes.
Right, cognitive overload, even for an AI.
Sort of, yeah. And it also allows you to smoothly integrate external knowledge and tools at each step. So the agent isn't limited to just its training data.
Ah, okay, so it can pull in outside info along the way.
Precisely. This whole sequential method is crucial for multi-step reasoning, putting information together, especially when a single question needs more than one piece of data to answer properly. It gives you precision, control.
That makes perfect sense. So for your mission, supporting domestic violence crisis response, prompt chaining sounds absolutely vital for reliable, context-aware, safe responses. How might that look?
Oh, it's a game changer there. Imagine your crisis chatbot. First prompt, maybe intent ID. Is the user in immediate danger? What kind of support do they need?
Right.
The output might be structured data like danger level, high support, emergency shelter.
Okay, clear output.
Then some deterministic logic, just normal code you write kicks in. If danger level is high, bam, it branches to an emergency protocol. No LLM guesswork there.
Yeah.
Then maybe a second prompt. Info gathering. Okay, they need shelter. What info do we need to provide or collect to help? And crucially, it gets that support tech emergency shelter from step 1 as input.
Following the chain.
Exactly. And finally, maybe prompt 3, resource lookup response. Based on everything we know now, draft a response suggesting the nearest shelter, give contact details. See? This methodical approach ensures precision, minimizes errors, builds that crucial trust.
That's a brilliant breakdown. Really paints a picture. And for listeners wanting to implement this, frameworks like LangChain, LangGraph, Google's ADK, they'll structure this, right?
Yeah, they provide environments specifically designed for defining and executing these exactly like that. It holds info being currently processed. For the LLM, that means recent messages, tool usage, reflections, whatever fits inside its context window.
The context window. That's the limit on how much it can see at once.
Right. It's a limited buffer. And this short-term memory is ephemeral. It vanishes when the session ends.
So you need to manage it carefully.
Yeah, efficient management might mean summarizing older parts of the conversation or maybe emphasizing key details to make sure the important stuff stays within that limited window.
Okay, that's short term. What about remembering things longer across interactions?
That's long-term memory or persistent memory. Think of this as your personal library or archive. It's a repository for information you want to keep across different interactions, tasks, maybe over long periods.
Stored externally, not just in the LLM's immediate view.
Correct. Stored externally in things like databases, knowledge graphs, or specifically vector databases.
Vector databases.
Yeah.
You mentioned those.
Yeah.
They're specialized.
Highly specialized. Imagine every piece of text gets a unique numerical fingerprint and embedding. Texts with similar meanings have fingerprints that are close together in this abstract number space. A vector database is built to find similar fingerprints really, really fast. This lets you do semantic searching by meaning, not just keywords, crucial for true persistence.
That's a great way to put it, the specialized library for meaning. Now, Google's ADK, the Agent Development Kit, has a structured way to handle this, right? Session, state, memory service.
It does, yeah. Very structured. A session is basically one individual chat thread, like one continuous conversation. It manages its own life cycle start, recording messages and actions called events in ADK, storing temporary data for that chat, say state, and then ending.
So for our crisis bot, each time a user reaches out, that's one session.
Exactly. Each support conversation is its own session.
And how do we manage these sessions? How do we make sure they stick around if needed?
ADK gives you options for the session service. There's in-memory session service, good for quick tests where data loss is fine. Then database session service for persistent storage, maybe using a simple SQLite file. And for serious production, especially in critical apps like yours, you'd look at Vertexi session service. That's robust cloud-based storage on Google Cloud.
Got it. And within that session, you mentioned state. Session.state. That's the scratch pad just for this conversation.
Precisely. .session.state is like a dictionary holding dynamic data just for the active chat. User preferences for this interaction, task progress, flags to guide the conversation flow. ADK uses neat key prefixes for scope.user, .for data across all sessions for that user, like user.preferredlanguage.app.app for data across all users of the whole application, maybe app.system status. And temp for stuff only relevant to the current turn. Gone after that.
Okay, so for our crisis bot, you could track user.needs-legal-aid across sessions or session.current escalation status just for this chat. That makes sense. But you mentioned a warning. You can't just fiddle with session.state directly.
Right, critical point for reliability, especially when every interaction counts. Direct modification is a no-no. It can cause persistence issues, concurrency problems, data not saving right, different parts overwriting each other, big mess.
So how do you update it safely?
You use the specific mechanisms ADK provides, either via the output key on an LF agent if a simple reply also needs to change state, or by using eventActions.stataDelta when you append an event using sessionservice.appendEvent. These are the safe, managed ways to update that scratch pad. Ensures everything is logged and saved correctly.
Okay, that's a super important pro tip. So state is the active scratch pad. How does the bot remember key stuff across many interactions, building up that lasting knowledge? That's the memory service.
That's exactly where ADK's memory service comes in. It's for that long-term persistent knowledge. It manages the searchable repository of info from past interactions or maybe external documents you've loaded in. You add info using things like add session to memory, which pulls relevant stuff from a completed session. And the agent retrieves info by querying the store with search memory.
So for your work, this could store generalized knowledge on crisis intervention, common legal questions, may be successful, anonymized, de-escalation scripts, patterns from past cases to inform future chats.
Precisely that. Implementation-wise, again, options range from in-memory memory service for testing up to Vertex Air RAG memory service for scalable, persistent semantic search using Google Cloud's infrastructure.
Makes sense. And other popular frameworks like LangChain and LangGraph also have memory tools, right?
They do. LangChain has chat message history for manual tracking of the conversation, and conversation buffer memory is more automated, making the history available to prompts, often using a key like memory key history. It can give you the history as a string or a list of message objects. Flexible.
The source material drew parallels to human memory types.
Yeah, that's a helpful analogy. Semantic memory for facts and concepts, user profiles, domain knowledge. Episodic memory for past events or actions useful for few-shot learning, showing the AI examples of how to do something. And procedural memory for rules and instructions, often the system prompt itself, maybe refined via reflection techniques.
Okay. And then there's Vertex Memory Bank. Sounds quite advanced.
It is. It's a managed Google Cloud service using Gemini models. Think of it as an intelligent assistant that watches your bot's conversations asynchronously. It extracts key facts, user preferences, stores them persistently, usually linked to a user ID. It updates intelligently, even resolving contradictions if a user changes their mind later. You can retrieve info via full recall or similarity search.
Wow. So for a crisis bot, that means it could truly remember an individual's specific history, previous support, ongoing needs, even across different chats days apart.
Absolutely. That allows for a truly personalized, empathetic experience, which is just vital in crisis support. And importantly, it's designed with strict privacy and data anonymization protocols in mind. It integrates smoothly with ADK and has APIs for LangGraph or Crew AI too. Very practical for production.
Okay, let's shift gears. How do agents go beyond their internal knowledge and interact with the external world? A superhero team needs tools, right? Access to outside help.
Yeah.
First up, the Model Context Protocol, or MCP. You call it a universal adapter.
Yeah, that's a good way to think about it. MCP's core idea is standardizing how LLMs talk to external systems. Imagine having devices with all different plugs, then suddenly a universal power outlet system arrives. Any device plugs into any source. MCP is like that for AI. It lets any LLM, Gemini, GPT, Mixtral, Claude plug into any external system, database, or tool without needing custom code for each connection.
Okay, a standard plug.
Exactly. It's an open standard for how LLMs get context, execute actions, interact with different operational environments.
How does this compare to the tool function calling that many might know from building simpler bots? Is it different?
Big differences. Tool calling is often proprietary, vendor-specific. MCP is open and standardized, promoting interoperability. Big win. MCP's scope is broader too. It's a whole framework for discovery and communication, while tool calling is more direct function execution. Architecturally, MCP uses a client-server model. Your LLM acts as a client, talks to an MCP server, which then handles the tools. Tool calling is usually more direct element-to-app logic.
And you mentioned discovery.
Right. Dynamic discovery is key. MCP lets agents ask a server what tools and capabilities it offers. Tool calling usually needs the tools predefined. Plus, MCP encourages reusable standalone MCP servers, easier to share tools across agents.
That dynamic discovery sounds incredibly powerful. What are the key pieces inside MCP that make this work?
Three main things. Resources. Static data the agent can read. Think PDFs of legal guidelines, database records of shelters, tools, executable functions the agent can do, like send mail, query local database, contact emergency services, and prompts, templates, guiding the LLM on how to use a resource or tool effectively. Structured interaction.
And it's a client-server setup?
Yep. LLM is the brain, MCP client is the go-between app around the LLM, MCP server is the gateway exposing the tool's resources, and sometimes there's a third-party service, which is the actual external thing, like Google Maps API.
For our listener building that crisis response bot, this sounds huge. How does MCP help there specifically?
Oh, it's a massive enabler for applications like that. Imagine an MCP server dedicated to crisis resources. It could expose tools like find nearest shelter location, contact legal aid, issue type, send anonymous message, recipiented message, and resources like up-to-date PDFs of local legal rights, a database of crisis hotlines, FAQs from support orgs.
Oh.
The power of MCP is your agent can dynamically find and use these services without you needing to rewrite code for every new tool or data source. It makes sure critical services are always available, accessible, standardized. Your bot becomes incredibly versatile, adaptable.
That adaptability is key. What are some important things to keep in mind when implementing MCP, especially for sensitive work?
Good question. The underlying APIs need to be agent-friendly. Think filtering, sorting, not just old wrappers dumping raw data. Security is obviously paramount. Robust authentication, authorization, who can access what. Error handling needs to be clearly defined in the protocol. How does the LLM know if something went wrong? Discoverability is that key advantage. And SDKs like FastMCP for Python make building clients and servers easier. Communication uses things like JSON RPC over standard I/O locally, or streamable HTTP SSC for remote stuff. Just the plumbing details.
Got it. Okay, let's move to another critical pattern for connecting AI to the real world. Knowledge retrieval, or RAG. We hear about LLMs hallucinating, making things up. That's the problem RAG tackles.
Exactly. That's the core problem. LLMs are amazing at text generation, but their knowledge is stuck in their training data, often static, not real-time. This leads to outdated info, inaccuracies, or just fabricated stuff hallucinations. And for crisis response, hallucinations are completely unacceptable. Information must be accurate, current, verifiable.
So RA is like giving the AI an open book exam, can look things up before answering.
Perfect analogy. That's precisely it. When you ask a question, the RAG system first does a semantic search across a big external knowledge base. Your docs, databases, the web maybe. It finds the most relevant snippets of information. Those snippets get augmented, basically added to your original prompt.
Enriching the prompt with facts.
Right. This enriched prompt, now armed with factual context, goes to the LLM, which then generates a factually grounded, accurate response.
Why does this matter so much? Particularly for sensitive areas like crisis support.
Oh, it's vital. It gives access to up-to-date info, beating the static training data problem. It massively reduces hallucinations by grounding answers in real data. It lets the AI use specialized knowledge like your organization's specific policies that the base LLM never saw. And crucially, it can provide citations, links back to the source docs, that hugely boost trustworthiness, which is everything in crisis work.
Okay, to really get RAG, we need to unpack a few core ideas. Can you walk us through embeddings, similarity, chunking, vector databases?
Sure. Embeddings. Think numerical fingerprints for text. Every word, sentence, document gets a unique string of numbers. Similar meanings, similar fingerprints. Text and semantic similarity. Measuring how alike texts are based on meaning, not just keywords. RAG uses the semantic search. Chunking. Breaking big documents, legal docs, shelter lists, into smaller, manageable pieces or chunks. Preserves context, helps retrieval. Vector databases. Those specialized databases, Pinecone, Weaviate, ChromaDB, built to store and rapidly search embeddings using similarity. They make semantic search scalable. Retrieval techniques includes vector search, meaning-based, BM25, keyword-based, like traditional search, and hybrid search, combining both.
Great overview. Now, you mentioned Agentic RAG. What makes that smarter than standard RAG?
Agentic RAG is the next evolution. Here, an agent doesn't just passively accept retrieved info. It actively interrogates it, like a critical researcher. It performs reflection and source validation. Looks at metadata, dates, authors to prioritize reliable, current sources. Recognizes an official 2025 policy beats a 2020 blog post.
So it judges the quality of the information.
Exactly. It reconciles knowledge conflicts, finds contradictions, prioritizes better sources, final report over initial proposal. And it does multi-step reasoning, breaks down complex questions, queries multiple times, synthesizes info from different pieces. The challenges: more complex, potentially higher cost and latency, and the agent's reasoning itself could be flawed, but the potential for accuracy is huge.
For our listeners' crisis bot, Agentic RAG sounds like it offers potentially life-saving accuracy. How does it directly prevent harm?
It's absolutely critical. Ensures accurate resources grounded, verified info on shelters, legal aid, etc. Guarantees policy adherence using the latest organizational protocols. Crucial for avoiding misinformation, no hallucinations about safety plans or legal rights. Provides cited information links to official sources, build trust. And Agentic RA specifically, it can validate multiple sources on complex things like legal aid eligibility, ensuring the most current advice, or synthesize intricate details about protective orders from diverse local laws. That active validation is key.
And we saw practical code examples too. Using Google Search and ADK for basic RAG, setting up Vertex ARAD memory service for scalable semantic search on Google Cloud, or full LangChain implementations, loading, chunking, embedding into vector stores like Mediate. The core idea is there across the tools. Okay, let's talk agents working smarter, faster. A superhero team needs efficiency, right? Sometimes that means doing multiple things at once. First pattern here, parallelization.
Right. Many complex agent tasks have subtasks that don't depend on each other finishing first. Parallelization just lets these independent tasks run simultaneously.
Instead of A, then B, then C.
Exactly. It's like task A and task B run at the same time, then maybe task C uses both their results.
What's the big benefit?
Speed. It significantly cuts down overall execution time, especially when tasks involve waiting for external things like APIs or databases. Those have built-in delays. It makes the whole system much more efficient, more responsive.
Can you give a few examples where this shines?
Sure. Information gathering. An agent researching a company could hit news feeds, stock data, social media all at once. Data processing. Running sentiment analysis, keyword extraction, categorization on customer feedback simultaneously, multi-API interaction. A travel agent checking flights, hotels, local events concurrently gets you the full picture faster.
So for our domestic violence crisis bot, this means rapid initial assessment when speed is critical.
Absolutely critical. When someone reaches out in crisis, you need comprehensive info fast. Your bot could, simultaneously, query a database for shelters and search for legal aid contacts and run sentiment analysis on the user's message to gauge their state.
Wow, okay. Get a full picture quickly.
Exactly. It gathers a comprehensive initial understanding, prepares a multifaceted response much faster than doing it step by step. Or, if a user lists several needs, parallelize the lookups for each resource. Holistic answer, no waiting.
And implementation-wise, LangChain Expression Language, LCEL, helps structure things for concurrent runs. LangGraph can have multiple nodes fire off at once, and Google ADK has native stuff like Parallel Agent.
Yeah, the ADK example showed a parallel web research agent running 3 Agent instances at the same time for different topics, with a merger agent pulling the results together. Very practical.
Okay, next up, inter-agent communication, or A2A. The problem here is isolated AI, right?
Yeah.
Agents unable to talk or collaborate, like superheroes who can't coordinate.
That's the core issue. Individual agents, even smart ones, hit a wall if they can't work with other specialized agents. Limits the complexity they can handle. A2A is an open HTTP-based standard designed to fix that. It lets agents communicate and collaborate regardless of their underlying framework, ADK, LangChain, Crew AI, whatever.
Fostering a multi-agent ecosystem.
Precisely. Where specialized agents can team up, delegate tasks, share info. The main players are the user, the A2A client, acting for the user, and the A2A server, the remote agent processing request. The server is opaque. The client just needs to know what it can do, not how.
And how do they find each other?
Yeah.
Know what skills are available?
Through the agent card. It's like a digital business card in JSON format. Defines the agent's identity. Name, description, URL, version, interaction modes, and crucially, its skills. Like a weather bot might list get current weather and get forecast. This card is key for dynamic discovery.
How does that discovery happen?
Various ways. A standard web address, .wellknownagent.json, curated registries or catalogs, or just direct configuration. Lets clients find those agent cards.
And how do they actually talk? What if it's a quick question versus a long process?
A2A supports multiple interaction mechanisms. Synchronous request response, send task for quick, immediate stuff, back and forth chat. Asynchronous polling for longer tasks. Client sends request, checks back later for status. Streaming updates, SSE via send task subscribe for real-time incremental results. Server pushes updates as they happen. Push notifications, webhooks for very long tasks. Server tells client when something significant happens. And importantly, A2A is modality agnostic. Text, audio, video, it can handle the communication.
This sounds incredibly useful for orchestrating that crisis response team of agents. Different specialists working together.
It really is. Imagine an intake agent gets user input, identifies needs. It then queries a resource discovery agent, an A2A server, specializing in finding shelters, legal aid. For complex or high-risk cases, the intake agent sends a send task to a human escalation agent for seamless handover. Need translation. The intake agent dynamically finds and delegates to a language translation agent.
Wow. A modular, scalable system.
Exactly. A2A lets these specialized agents, maybe built differently, communicate and delegate. Creates a robust crisis support system. We saw ADK examples for setting up A2A servers too.
Okay, so agents collaborating. Now let's look inside their heads, reasoning techniques. The problem. Simple reactive answers aren't enough for complex issues. Agents need to break things down, use logic, interact with tools. Like an investigator.
Absolutely. These patterns help agents formulate transparent multi-step plans. Makes their thought process explicit. Foundational for autonomy and user trust. You can see how it got the answer. Key techniques include self-correction. This is an iterative loop. Draft output, review against requirements, refine.
The agent critiques itself.
Yeah, identifies weaknesses, suggests improvements, generates revised content, like an agent drafting a social media post, reviewing it for engagement, tone, call to action, then tweaking it.
How would that apply to a crisis bot? Seems vital for sensitive communication.
Definitely. A crisis bot could self-correct its empathetic responses, ensure safety instructions are crystal clear, refine its tone, make it more supportive, less prescriptive, huge in domestic violence contexts. It asks itself, is this truly clear, empathetic, actionable before sending?
Powerful. What other reasoning techniques are key?
Program-aided language models, or PaLMs. Here, the LLM generates and executes code, usually Python, as part of solving the problem. It offloads complex calculations or precise logic to a deterministic programming environment. Gets you precision.
So for the crisis bot,
It could generate Python code to process specific case data, like calculating available support funds based on complex rules, or verifying program eligibility with exact logic. Things LLMs alone might fumble. Then there's deep research, like Google Deep Research. Agent-based systems for autonomous info retrieval and synthesis. They dynamically query sources like Google Search, evaluate the data, search again to fill gaps, then consolidate vetted info into a structured report with citations.
like a research assistant on steroids.
Pretty much, for a complex legal question in a crisis. An agent could use deep research to gather precedents, local regulations, policy details, synthesize it for a human advocate, or inform a nuanced AI response, citing sources. Ensures a thorough, legally sound advice, minimizes misinformation risks. And finally, the scaling inference law. This basically says a model's performance improves if you give it more computational resources, a bigger thinking budget during inference when it's generating the response.
So more thinking time helps.
Yeah, and interestingly, a smaller model with a larger thinking budget can sometimes outperform a bigger model that's rushed.
Counterintuitive. So it's not just about the biggest model, but smart resource allocation.
Exactly. For crisis response, it's balancing latency, accuracy, cost for high-stakes, complex situations. Maybe allocating more thinking time even to a smaller model for careful reasoning and validation is better than a super fast but less robust answer.
When should we use these reasoning techniques?
Rule of thumb. Use them when the problem's too complex for one shot. Needs breaking down, multi-step logic, external tools, strategic planning, when the how the thought process is as important as the what's the final answer.
Okay, we've covered powerful capabilities. But with power comes responsibility, especially in domestic violence crisis response. This final section is crucial, ensuring trust, safety, and continuous improvement. Let's start with human in the loop, or HITL. What's the fundamental AI limitation this addresses?
The fundamental issues at AI, particularly LLMs, really struggle with nuanced judgment, ethical reasoning, deep understanding of complex human contexts, and genuine empathy. They just don't have it. So full autonomy in high-stakes areas carries huge risks: safety, financial, ethical. AI lacks creativity, common sense.
So HITL isn't AI replacing humans, it's a partnership, augmenting human skills.
Exactly that. Strategic integration. Combining human cognition, judgment, creativity, empathy with AI's computation. It ensures AI stays within the ethical boundaries, follows safety protocols, achieves goals effectively. It augments human abilities. Critical judgments still need human understanding.
How does that look in practice?
Key aspects include human oversight monitoring performance via logs, dashboards, intervention and correction AI, asking for human help with errors or ambiguity, humans step in, fix, guide. Human feedback for learning, refining AI models via feedback loops. Decision augmentation AI provides analysis, recommends. Human makes the final call. Human agent collaboration AI does routine tasks. Human handles the complex creative stuff. And crucially, clear escalation policies rules for when and how an agent must hand off to a human.
There was also a human-on-the-loop variation mentioned. How's that different?
Slightly different angle. Human defines the overall policy or strategy, then the AI handles immediate actions autonomously to comply. Think. Call center manager sets policy. If user frustration is high, offer human agent. The AI then executes that rule automatically for each case. Human sets the principle, AI executes.
Okay. For a domestic violence crisis response bot, HITL isn't just nice to have. It's absolutely critical, non-negotiable, right?
Paramount. Non-negotiable. AI cannot do empathy. HITL ensures sensitive, emotional, ambiguous cases go to a human advocate who can provide that vital connection. It's the safety net. AI flags dangerous or complex situations it can't handle, threats, legal tangles, immediately transferring to a trained human. enforces ethical boundaries. Human review makes sure AI responses align with crisis intervention ethics, maintaining trust, enables continuous learning. Human advocates give feedback, helping the model get better at spotting and responding to crisis cues over time. The ADK code example showed a tech support agent using Escalate solo human. Your crisis bot must have escalated human advocate built in. Day one priority.
Absolutely. Building on safety, let's talk guardrails and safety patterns. What's the core danger with autonomous agents here?
The danger is unconstrained, unpredictable AI. Agents generating harmful, biased, irrelevant, incorrect stuff. They're vulnerable to adversarial attacks like jailbreaking users, tricking them into breaking rules. Unintended behavior destroys trust, causes legal and reputational harm, unacceptable in crisis work.
So guardrails are like a multi-layered defense system, keeping the AI on track.
Precisely. Crucial mechanisms ensuring agents operate safely, ethically, as intended. A protective layer. Not to limit capability negatively, but ensure robustness, trustworthiness, beneficial operation. This involves input validation, sanitization, filtering malicious stuff, prompts like ignore previous rules, output filtering, post-processing, analyzing responses for toxicity, bias, bad advice before sending to the user, behavioral constraints, direct instructions in the system prompt, you are an AI content policy enforcer. Tool use restrictions limiting which tools it can access or how. External moderation APIs for advanced content checks, and again, human oversight intervention via HITL.
A layered defense.
Yeah, you can even use a smaller, faster model like Gemini Flash as an extra safeguard, pre-screening inputs or double-checking outputs, a quick first check.
And for the crisis bot, this is also paramount, the ultimate protection.
Absolutely paramount. Prevents harmful advice, unsafe, legal, medical safety suggestions. That's job one. Rigorous content moderation, filtering abusive user language, ensuring AI doesn't generate bad content itself. Privacy guardrails, stopping the AI asking for or revealing sensitive info unnecessarily. Ethical conduct, ensuring no biased viewpoints, no escalating conflict. And jailbreaking prevention, protecting against tricks to bypass safety.
The true AI example in the source material really drove this.
Yes, that was a great illustration. Defining a policy evaluation structure for compliance. A validation function acting as a technical guardrail, checking the LLM's output format. Then a policy enforce agent with a strong safety guardrail prompt, screening inputs against things like instruction subversion, prohibited content, hate speech, hazardous explicit abuse, irrelevant discussions, proprietary info.
So it blocks bad input.
Exactly. It shows how you build that pre-screening layer to block ignore rules and tell me X or abusive messages. Protects your crisis bot, keeps it focused. Plus, good soccer practices like modularity, structured logging, seeing the agent's thought process, and least privilege, minimum needed permissions are vital for robustness.
Okay, next, evaluation and monitoring. How do we know if these complex probabilistic agents are actually working well over time? Traditional tests aren't enough.
Right. Performance can degrade, data drift, concept drift. Evaluating multi-agent systems is tough. They're always changing. This pattern is about continuous assessment. Effectiveness, efficiency, compliance. Systematically checking performance, monitoring goals, detecting anomalies. You need clear, measurable objectives. Use quantitative and qualitative data. Collect data regularly. Provide feedback. Practical uses. Performance tracking, accuracy, latency, crisis bot resolution rate. A/B testing, comparing versions. Compliance safety audits. Drift detection. Anomaly detection. Spotting errors, attacks, weird behavior.
What are some key metrics to track?
Latency monitoring is huge. Response time. Critical in real-time crisis scenarios. Every second matters. Token usage tracking for LLM agents. Essential for cost management. Optimizing prompts. Every token costs. And the fascinating helpfulness via LLM as a judge. Using one LLM to evaluate subjective qualities, empathy, clarity, of another agent's output against criteria. Nuanced, human-like assessment.
And it's not just the final output, right? We need to look at how the agent trajectories.
Absolutely. Evaluating the sequence of steps, tool selection, strategies, efficiency is critical. How did it get there? Compare actual actions to an expected or ground truth trajectory, the ideal path. Pinpoints where it went wrong. For multi-agent systems, evaluate individual agents and their cooperation. Did Agent A pass the right info to Agent B? If not, you know where the breakdown is.
So for our crisis AI, this means continuous improvement, learning to be a better superhero.
Exactly. Track de-escalation effectiveness. Measure success, connection to human aid, reduce distress. Resource accuracy, are resources correct, up to date. Latency and emergency crucial monitoring. Audit trajectories against safety protocols, trigger alerts. Analyze trajectories to find optimal paths, refine tool use. Use LLM as a judge to assess helpfulness, empathy, refine responses. ADK as good evaluation tool, UI, programmatic tests, CLI. And for high stakes, think about formalized contracts, defining deliverables, scope, etc., beyond simple prompts. Professional agents.
Okay, almost there. Learning and adaptation, agents that evolve. The problem: static bots in a dynamic world don't cut it. Environments change.
Exactly. Agents need to handle unpredictable, changing new situations. Pre-programmed rules are too brittle. The concept is agents changing strategy, understanding, even goals based on experience. Adaptation is visible change from learning. Key algorithms mentioned, like PPO and DPO, are basically advanced ways for the AI to learn safely from experience and human feedback, getting better over time, making the AI truly adaptive.
How does this apply practically?
Personalized assistance learning habits, trading bots adapting to markets, fraud detection evolving, recommendation agents, and critically for you, knowledge-based learning agents using RAG to keep a dynamic wisdom base of problems and proven solutions.
The self-improving coding agent, Ch0 case study sounded wild. An agent rewriting its own code.
It is cutting edge. Ch0 modifies its own source code to improve performance, like a self-improving engineer. Uses modular subagents and overseer LLM monitors and intervenes, needs careful context window management, Docker for safety. Google's AlphaVolve is similar, AI discovering and optimizing algorithms, finding new matrix multiplication methods, AI helping us innovate.
So for our crisis bot, this could mean an evolving crisis response system, getting smarter over time.
Precisely. Adapt de-escalation strategies based on success feedback. Learn user preferences for personalized support. Core logic might refine itself to spot distress cues better, access resources more efficiently based on success rates. A knowledge-based learning agent updates its RX store with new effective intervention patterns. Use this for dynamic, uncertain environments needing personalization, continuous improvement, handling novelty.
Finally, exploration and discovery, uncovering new possibilities. Problem: just reacting or optimizing known solutions isn't enough for open-ended complex domains. Need to think outside the box.
Right. This pattern lets agents proactively seek novel info, uncover new possibilities, find unknown unknowns. Experimenting, generating new knowledge. Google's AI co-scientist is a prime example. Ideation to validation. Iterative generate, debate, evolve, cycle mirroring science, multi-agent system, supervisor generation review, etc. Achieved real results. Novel drug candidates explaining resistance patterns. Critically, it's scientists in the loop, human collaboration, not full automation. Safety review is key.
And the agent laboratory, agents running experiments.
Yeah, a framework for autonomous research. Phases. Literature review, LLM agents, experimentation, automated Python hugging face, report writing, knowledge sharing, agent Ch0. Even uses tripartite agentic judgment, 3 agents evaluating outputs from different angles for rigor, specialized agents for review, ML engineering.
Truly boundary pushing. How could this innovate crisis response, moving beyond reaction?
This is about proactive discovery. How can your AI find new ways to help? An exploration agent could analyze anonymized data to identify emerging needs, new types of violence, new survivor challenges needing novel strategies. Optimize resource allocation, explore. Discover most effective resource combos or sequences. Find underused local support. Perform hypothesis generation. Why are certain interventions better for specific groups? Inform policy, practice.
So the AI becomes a partner in shaping better outcomes.
Exactly. Moving beyond reaction to actively shaping better outcomes. Uncovering unseen connections, opportunities, making the AI a partner in prevention and innovation. Use this for open-ended, complex domains where solutions aren't defined. Generate novel hypotheses, strategies, insights. Find those unknown unknowns. #tab outro.
Wow, okay. What a journey. That was a truly comprehensive deep dive today. Covered so much ground.
We really did. From the basics like prompt chaining in memory.
Right, giving the AI structure and recall.
To how they connect to the world with MCP and RG, getting external facts into
A smart library access. Then we hit collaboration and reasoning parallelization, A2A, those reasoning techniques.
Letting agents work faster, smarter, even critique their own thinking.
And then, so crucial for your mission, listener, trust and continuous improvement. HITL, guardrails, evaluation, learning, adaptation, even exploration.
The Responsible AI Foundation, absolutely key.
You should now have a really solid mental map of these agentic design patterns. Not just theory, but practical architectures, tools, code concepts you can actually implement.
Yeah, think of it as being equipped to build. Each pattern is a new superpower for that crisis response team you're assembling.
And as someone building these AI solutions for domestic violence crisis response orgs, you're right at the forefront, applying powerful tech to deeply human problems.
It's vital work. And remember, every pattern, the fact-checking of Agentic RAG, the essential human oversight in HITL, the protection of guardrails, it all builds an AI that's not just smart, but safe, reliable, empathetic.
It's ethical design leading to profound impact.
Absolutely.
So as you start integrating these agentic patterns, here's something to think about. What new possibilities could your agentic system uncover? Not just reacting to crisis, but actively shaping better outcomes.
Discovering innovative ways to support and protect vulnerable individuals. How can your AI be an active partner in preventing harm, not just responding to it?
That's the provocative thought for you. We're genuinely excited to see what you build. Keep experimenting, keep learning, keep asking how AI can serve our most pressing human needs.
The journey to truly impactful AI is ongoing. Thrilled you're on it.
That's all for this deep dive. We really hope this gave you a clear advantage in navigating the exciting, complex world of agentic AI. Until next time, keep diving deep.